Alright, so today we're going to talk about curve fitting with linear models. So we're going to use what we've talked about graphing. We're going to use what we've talked about with equations of lines. And today we're going to talk about how you can apply this kind of in real life. Okay, so curve fitting with linear models, section 2.7. Vocabulary. Regression. Regression is the statistical study of the relationship between variables. Alright, so we're going to talk about the relationship that like scatter plots can have or show. Correlation. Correlation is a measure of the strength and direction of the relationship between two variables or data sets. I can have three types of correlation. I can have a positive correlation. Positive correlation is a lot like positive slope. It's going to go up. No correlation. That means like there's no relationship. It's kind of hit or miss. It's really scattered. There's no relationship between them. And then I have a negative relationship. Negative relationship is like a negative slope. It's going to go down. Okay, so positive slope goes up, negative slope's going down. All right, then I'm going to have line of best fit. Line of best fit is the line that comes closest to all of the points in a data set. The line of best fit is kind of like the line, like the average line that you can draw through all the points. So what's like the best line you can draw through there? Then I have the correlation coefficient, which is kind of more statistical based. But correlation coefficient, a number r, where negative 1 is less than or equal to r, which is less than or equal to 1. Basically, my correlation coefficient will always be between negative 1 and 0. It's 1 if it's really strong positive, and it's negative 1 if it's strong negative, and it's 0 if it's weak. And then I have my correlations. A positive correlation, okay, I'm going to go up. So positive correlation, I'm going up. It shows a positive slope. That makes sense, right? Positive slope, positive correlation. Negative correlation, I'm going to go down. And no correlation, it's kind of all over the place. Okay, so you look there, it's kind of all over. So that's the negative correlation, or that's the no correlation. Here's what we're going to do today, though. We're going to look at scatter plots, and we're going to draw a line of best fit, and then write an equation based on that line. Okay, so what this looks like here is I'm given ordered pairs. Everybody see the ordered pairs? I plot the ordered pairs. Okay, so you notice they plot the ordered pairs. And then I'm going to draw the line of best fit through those ordered pairs. Now notice, a line of best fit is what line would basically be like the best average of all those points. Now does everybody agree? I could probably draw a line right there through those 2 points, right? Would that be a good line for that set of data though? No, that wouldn't be a good line. Could I draw a line something like that? Would that be a good line for that set of data? No, not for where the points are, okay? If you look where the points are, I want something that's going to do a good job of going through those points. My key to this, I would always want my line of best fit to go through about 2 to 3 points. Okay? And I want an equal number of points above the line and an equal number of points below the line. Okay? So if I'm doing this, I want to have a line of best fit where I want my line to go through about 2 or 3 points. If I can go through more, great. I want it to go through more. But I always want about the same number of points above the line as the same number of points below the line. So it's a good average. Does that make sense? You kind of consider it the average. Now, why do I want to go through 2 or 3 points? Well, because I want to use those points to find the slope. So notice here, I'm going to go through points. I use those points, and now I find the slope. All right, and then what do we do once we find the slope? We use that slope and one of those points, and I plug it into point slope form, and then can change it to slope intercept form. Okay, and that is the key to all of this. All right? So let's look at number 1 here. It says, make a scatter plot of the data below, draw a trend line, and write its equation. I'm going to put these little squiggles down here in the corners. Does anybody know what those little squiggles represent? What is it? It's a paper break. What's a paper break mean? What am I not starting at? I'm not starting at 0. So paper breaks like, basically I'm breaking off the paper. I'm kind of showing you a sample of the whole graph. So I'm not starting at 0, 0 is what this says. Okay, so length is going to be my x. Wingspan is going to be my y. All right, I'm going to start at, I don't know what I'm going to start at here. I'm going to start at 16. I'm going to go by 2s. So 16, 18, 20, 22, 24, 26, 28, 30. Okay? And then when I go up, I'm going to start at 30, and I'm going to go by 3s. How about that? So I'm going to go 30, 33, 36, 39, 42, 45, 48, 51. Does everybody see how I kind of just made my scale? All right, the biggest thing when I'm making my scale here, I have to go up by the same amount. So I can't go up 3 this time, up 5 the next, right? So if I'm going all my x's, all my x's are up by 2s, all my y's are up by 3s. Okay, now I'm just going to plot coordinates. So I have 21, 36. So I'm going to go 21, 36. I'm going to plot that coordinate right there. I have 21, 41. Okay, plot that coordinate there. 18, 38. 24, 46. 16, 31. 19, 39. 17, 35. And 1946. Okay, so now I have my dots here. First off, what type of correlation do I have here? What did you think? Positive correlation. Does everybody see it's kind of going up, right? Positive correlation. Now, as I do this now, I want to find some points to draw my line through. Would those be 2 good points to use? Are those 2 good points for my line? No, I would not use those 2 points. I want to find points that kind of summates or averages it. Would that be a good line here? Why would that one not be a good line? Yeah, there's way more on the bottom. Like, that's not a good average. Would this be a good line? Something like that. Why is that one probably a pretty good line? How many points is it going through? Well, it's going through at least 2, maybe 3 points there, right? I have 1, 2, 3 points above, 2 points below. Does everybody agree that's probably a pretty good average of that graph? Yeah, I'd say that's probably a pretty good average. Now again, why do I want to have it go through coordinates? Because next I need to find the slope. So to find the slope, I'm going to use this coordinate here, which was, what was that, 24, 46. And I'm going to use this coordinate here, which was 17, 35. So I'm going to use those 2 coordinates. Now I'm going to find the slope. Well, how do I find the slope when I have 2 coordinates? I use the slope formula, right? So I'm going to say 46 minus 35 over 24 minus 17. 46 minus 35 is 24 minus 17 is? I have my slope. Does everybody see how I get my slope here? 11 over 7. Next, I want to write an equation now. What equation would I probably want to use? What, Beast? I want to use point slope. Why? Because I'm given a point and I'm given a slope. Does it matter which point I use? Nope, I can use any one of those. I'm going to choose 1735. So I'm going to write an equation. Y minus 35 equals 11 over 7, parentheses, x minus 17. And there's my answer right there. So I'm making the scatter plot, and then I'm writing the equation based on that scatter plot. All right? How are we doing there? Feeling good? Yes, ma'am.
Did you just randomly pick 2 dots for the slope, or did you pick?
I picked 2 dots that my line were on. Like, for instance, I would not want to choose this dot. Why? Because that's not where my line's on. So that's why I always want my line to go through some points, because that way I can choose the points that are actually on that line.
What if it's like if it's no correlation?
If it's no correlation, then there'd be no equation there. Good question. So number 2, make a scatter plot of the data below. Draw a trend line, write its equation. So again, to start off, I'm going to make a paper break here. Now the years all go in increments of 1, so I'm just going to go 93, 94, 95, 96, 97, 98, 99. Okay. The dollars, I'm going to go by 50s. It's quite a bit there. So I'm going to start at 300 and go by 50s. So I have 300, 350, 400, 450, 500, 550, 600. Okay, now I have my graph set up. Now I'm going to plot coordinates. 1993 and 340. Somewhere about there. 1994 and 369. about there. 95 and 402. 96 and 430. 97 and 457. 98 and 489. 99 and 527. And then I have 2,000 and 574. What type of correlation does this one show? That's positive correlation again. Now, is this one, could you really probably mess this one up at all? No, this one makes a pretty good line already. Does everybody see that? So I'm just going to make some points here. Oh, that one's a pretty good one, right? I'll start there. I'm going to use that coordinate and that one right there. So what coordinates did I choose here? I chose 2,000, 574, and I chose 1996, 430. So I have my coordinates. Now I need to find my what? I need to find my slope. So I'm going to say, remember, this is my x, this is my y. So I have 574 minus 430 over 2,000 minus 1996. Well, what's 574 minus 430? 144, right? Over 2,000 minus 196. Does 4 go into 144? How many times? Is it 36 times? Yeah, 36 times. So I have my slope here. Now I need to write the equation of the line. So to write the equation of the line, I need to put it into point-slope form. Which point would I like to use? I want to use either one of the points I use for the slope. So which point do I want to use? Which one?
1996.
This one? Okay. So I'm going to write that equation. Y minus 430 equals 36 parentheses x minus 1996. And there it is.
Does it matter which one you put y minus?
What?
Does it matter which one you do, like y minus 430? You're going to be y minus 1996.
I always want to do y minus my y coordinate. Yep. All right, using that same idea. Try this one on your own now. Take a couple seconds, try this one on your own. All right, so let's walk through this one here. Here's my coordinates on my grid. I draw my line through here. I don't know. I like that one right there. I think that's a pretty good line. Kind of goes through that way. All right, so I have this coordinate here and this coordinate here. What was that one? That's 18, 120, and I have 50, 200. Those are the two coordinates I used. Again, you could have used some different coordinates. That's fine. Those are the coordinates I used. So I'm going to take my slope, 200 minus 120, over 50 minus 18. I get 80 over 32. 80 over 32 simplifies to, does anybody know it? 5 over 2. So I get slope of 5 over 2. Now I need to pick a coordinate. Which coordinate should I use? Does it matter? I'm going to pick 50, 200. I don't know, I just like that one. So I'm going to say y minus, what's my y coordinate? Equals, what's my slope? Parentheses, x minus 50. And there's the equation of the line. If I wanted to, could I change that to slope-intercept form? What do I have to do? When I just distribute, then add the 200? Yep. Nice job. All right, try one more on your own here. All right, try number 4 on your own again. Same idea. Make your paper break at the bottom. I'd go, I don't know, 3s, 4s, something like that on the bottom would be good. Your y-axis, you probably want to go by 10s or 20s, something like that. So if I look here, this should be my graph that I have. After I do that, find the line of best fit. Would that one be a good line of best fit right there? No. Would that one be a pretty good line of best fit? Ooh, not that one. That would be a pretty good line of best fit? Yeah, that's a pretty good one. So I'm changing those two coordinates, which are 527 and 22, 107. After I pick the coordinates, what do I need to do now? Find the slope. So 107 minus 27. over 22 minus 5. What's 107 minus 27 going to get me? 80? Just 80? And then 22 minus 5 gets me 17. Now that one does not reduce, so that's just going to be 80 over 17. Now that I have my slope, what do I want to do? Put it into point slope. I'm going to choose 527. So y minus 27 equals 80 over 17, parentheses, x minus 5. And there's the equation of my line now. Feel pretty good about this? So now, see how we're just taking everything? We're taking the graphing, we're writing in the equations, finding slope, taking everything we've done, basically the last 3 or 4 sections, and now putting it together here. Last thing we're going to talk about today is identifying some correlations. So it says, would you expect a positive, negative, or no correlation between the two data sets? Well, positive correlation means it goes up, right? Does everybody agree with that? Positive correlation is going up. What a positive correlation means is as one increases, the other increases. So as my x increases, my y increases. Or as my x decreases, my y decreases. Negative correlation means my slope's going to go down. What that means is as one increases, the other one decreases. And then I have no correlation. No correlation means it does not matter. Everything's just kind of out there. So let's look at the first one. Okay, first one, 5, says a person's age. The person's age and the number of pets he or she has. So is there any type of correlation between a person's age and the number of pets he or she has?
No.
There'd be no correlation there. Could you be a 20-year-old and have 5 dogs? Could you be an 80-year-old and have 5 dogs? Yeah, there's no correlation there, okay? And you can be a 20-year-old and have 20 cats. Okay, there's no correlation between the age and your pets. Number 6, the number of times you brush your teeth and the number of cavities you have. So if I brush my teeth a lot, do I have a lot of cavities? Well, if you don't brush them very good, I guess, too. But what type of correlation do you think it was, though? That'd be a negative correlation. Yeah, on average, this would be a negative correlation. What that's saying is if I brush my teeth a lot, I should have few cavities. If I don't brush my teeth a lot, I'm going to have a lot of cavities. 7, the number of days it rains per year and the number of umbrellas sold. If it's monsoon season, you think people are going to go out and buy some umbrellas? So that's going to be a positive correlation. Okay, so yeah, the correlations, as you're looking at the numbers, like on average, what would you expect? Using that same idea, try these 3 on your own now. Take a couple seconds, try these 3. Think them through. All right, so think about number 8 here. The number of empty seats in a classroom and the number of students seated in the class. What type of correlation do you expect, Jake O'Connor? Yeah, that'd be a negative correlation. Yeah, if there's a lot of empty seats, well, there's very few people seated. If there's no empty seats, there's a lot of people seated, right? Good job. Number 9, the number of pets a person owns, the number of books that person read last year. What are you thinking, Kyle? That'd be no correlation. Yeah, the number of pets you have, the number of books you read, and there's no correlation there. 10, the number of people in an audience in ticket sales. What do you think there, King? That'd be a positive correlation. Now, who thinks they can give me a real-life example, again, of a negative correlation? Can anybody give me something in real life where they can think of a negative correlation?